Okay, so that is about your time period. So time period of a simple harmonic motion is given by the formula T is equals to your 2 pi by your omega. The next term which we'll be using regularly is your frequency. Okay, so what is the frequency? Frequency is nothing but what, beta? Number of oscillations per second. This one is your number of oscillations. Number of your oscillations per second. Number of oscillations per second. So it is represented by F, or it is sometimes represented by N also, beta. So frequency will be equal to your reciprocal of your time period. So F is equals to your 1 by T. Okay, and the last term which we'll be using regularly in this one is your angular frequency. Angular frequency. Angular frequency represented by term omega, represented by term omega part of relation. So that is your angular frequency. Can you define an angular frequency? Angular frequency is nothing but number of oscillations per second, number of oscillations per second. Omega is also what for me? Number of oscillations per second. So omega is equals to 2 pi into your F beta. So F value will be equal to how much for me? 1 by T. So omega will be equal to how much for me? 2 pi by your capital T. SI unit of this one is, SI unit of angular frequency is radians per second. Radians per second. Is it clear? So omega is nothing but what? Number of
Yes, sir.
oscillation per second. So omega is equals to this one, or else omega is equals to your 2 pi by your capital T. And SI unit is radians per second. See, 2 pi is nothing but 360 degrees only, na? So this is the reason we are measuring that one in terms of degrees or radians. I'm writing in terms of 2 pi, but it is radians per your second part of relation. Clear for everyone? Is it clear, beta?
Yes, sir.
That was about your introduction related to this one, beta. So let me draw very fastly the graphs associated with this one. It leaves me, help me out. So if I'm trying to draw the graphs of this one. First one is I'm drawing the graph of your displacement displacement versus time graph. Displacement versus your time graph. Okay, so what is the displacement equation, beta? Displacement equation is x is equals to your a into your sine of your omega into t, isn't it? So assuming the initial phase to be 0, assuming initial phase, I'll tell you in detail about your phase, don't bother of that one. So initial phase is 0. That means phi value I'm taking it as of your 0 in the initial equation. So x is equals to a into sine of your omega t. Sine function kabatti, this will be starting from here like this. Sine function always starts from where, beta? Origin. So sine function is like this. So this is your x versus your t graph. Okay, so this will be your maximum
Yes.
displacement, beta. This one is your plus a, and this is your minimum displacement right now here. So this is your minus a. Is
Mm.
it clear? So this is the graph for your
Yes, sir.
displacement versus time. The next one is your velocity versus a time graph. Velocity versus your time graph. Velocity versus your time graph. Okay. So how do you get a graph right now? Tell me. So for velocity versus time, what is an equation, beta? V is equals to a into omega into cos omega t, kada? Isn't it? So if I'm drawing the graph
Yes,
for
sir.
the cos, so this is your graph. This is your velocity and this is your time t. So what I'll be getting the graph right now, whenever I'm starting from the cos, this will be your like this. One complete cycle. So this will be equal to how
Yes.
much, beta? A into your omega. And this will be equal to minus of your A into your omega. Minus of your A into your omega. This is your plus, because velocity will be equal to maximum value of cos is how much for me, beta? 1 gada.
Yes, sir.
And minimum value is minus. So this one will be
Minus.
minus of your A into your omega. Okay. So this is the velocity
Yes,
versus
sir.
your time graph. And third one is your acceleration versus time graph. Acceleration versus time graph. Now, if I'm talking about your acceleration versus your time graph, What is an equation of an acceleration, beta? Can you tell me? Acceleration of equation is A is equals to your dv by your dt, or that is equals to minus of your A into your omega square into sine of your omega t. This is a sine function. This is your sine function. So sine function always starts from where, beta? So this is your time, and this one is nothing but of your A. Sine function always starts from origin. It will always start from origin, but it is minus sign. If it is plus sign, we'll go like this, beta. If it is minus sign, we'll go from the down. Okay, na? So this sine function, this will be like this. Okay, na? So this will be equal to
Yes,
your
sir.
minus of your A into your omega square, and maximum displacement of this one will be equal to your plus of your A into your omega square. Is it clear? So it is very clear
Yes.
right now, the graphs of that one right now. So acceleration versus your time graph, velocity versus your time graph, and your displacement versus your time graph part of a relation. Is it clear? Is it
Yes,
clear,
sir.
beta?
Yes, sir.
Let me do one small question, then we'll start doing the working on this one, beta. See this question right now. Find the minimum time. Find the taken minimum time taken by a particle. Minimum time taken by a particle performing SHM. Performing SHM to go from number one, x is equals to 0 to x is equals to your a by 2, and number two, x is equals to your a by 2 to x is equals to capital A, and t is your time period, beta, right now here. So time period of oscillation, I'm taking it as of your capital T. Time period of oscillation. Time period of oscillation is capital T. What do you mean by that? That means for one complete cycle, the time period is given as of your capital T and them. Find the minimum time taken by a particle perform in SHM to go from your x is equals to 0 to x is equals to your a by 2 part of relation. That means what is the general equation of SHM which is performing what do you call that one, SHM, beta? If I'm starting from origin, x is equals to your a into your sine of your omega into t. Okay. Now say somewhere
Yes.
it is say at t is equals to t1. The displacement is how much? At t is equals 0, the particle is here, beta. At t is equals to t1, say for example, x is equals to how much for me? A by 2, isn't it? That means the particle is moving linearly like this. So here this one is x is equals to 0. Then after certain time, this is a t is equals to 0. Then after time t is equals to t1, this is at a position x is equals to a by 2. A by 2 అంటే half of the amplitude. ఇది మీన్, ఇది ఎక్స్ట్రీమ్ E1. ఈ రెండింటి మధ్యలో, అంతే కదా? So this is your a by 2. Total is how much from here to your a kada? From mean to your extreme
Yes,
is
sir.
your e. But half of that one, but it is a by 2. That means x value is how much? A by 2. In the place of x, you substitute a by 2. So if I'm taking right now here, a by 2 is equals to a into your sine of your omega into your t1. This a and this a will get cancelled right now. So sine of your omega into your t1 is equals to your half. For what value of half is it the sine value, beta? For what value of the sine?
30, sir.
Hmm? Enta? Sine 60 is how much?
Thir- Root 3 by 2, sir.
Sine 30?
1 by 2.
Pi by 6 and daskana. This one and this one will get
Yes, sir.
cancelled. Omega into t1 will be equal to your pi by 6. Omega value is 2
Yes,
pi
sir.
by your capital T into your this one is t1, that is equals to pi by 6. So this one in this one pi and this pi will get cancelled. So t1 will be equal to how much, better? T by 12. So after this much amount of your time, the particle is at your half of the maximum amplitude. That means time taken to go from your mean to half of the maximum amplitude is how much for me, beta? T by your 12 part
3
of
by 12.
relation. Is that clear? Then again, from
Yes,
where
sir.
condition we are going? X is equals to A by 2 to
Half
your
to
A,
the extreme.
half to your A part of relation. That means you see, listen it carefully right now. For second case right now, if I am putting, if I am putting X is equals to your A in equation 1, in equation 1. So we are going from where X is equals to 0 to, we are going to X is equals to your A. That means T is equals to T2, X will be equal to how much beta? A gada. So if I'm using the equation, X is equals to A into sine of your omega into your T2, X is equals to your A, that is also equal to your A into sine of your omega into T2. A and A gets cancelled right now from this one. So this is your 1 is equals to your sine of your omega into your T2. So for what value of the sine is it 1 beta? Sine 90. Antena?
Yes, sir.
Sine of
Yes, sir.
your pi by 2 will be equal to sine of your omega into T2. You need to remember all the trigonometric values right now in this chapter beta. Without that one, we can't do it out. So if you are not able to recollect it faster, you please try to go through all the trigonometric relations and values very faster way, because this is very much required in this topic beta. So this is your pi by 2, that is equals to omega. Omega value is how much beta? 2 pi by your capital T into your time taken is nothing but
Yes,
T2.
sir.
So this one and this one will get cancelled. So from this one, how much I'm getting? T2 will be equal to
T
your
by
how much
4.
were T by 4. Starting అనుకున్నాం మనం, అవునా కదా? From mean
Yes,
to
sir.
extreme పోవడానికి time ఎంత? T by 4. Again from extreme to
Yes,
mean
sir.
to come, it is nothing but T by 4. Total time will become how much for me? T by 4 part of
T
relation.
by 4.
But what is asking in the problem, you see, is asking is the time taken to go from your x is equals to A by 2 to your A. We already know the time at your A by 2, isn't it?
Yes, sir.
And we know already time to go from your x is equals 0 to x is equals to your A part. This is the time what we got. We are going from where to where? X is equals to your A. 0 to A పోవడానికి time ఎంత? T by 4. But we need
Yes,
to
sir.
go from where? A by 2 to your x part of relation. A by 2 to your x is how much for me? We are going right now for this one. If I'm drawing the diagram, you see, this is your diagram. Sorry. This one was your mean position, 0. This one was half of the amplitude, A by 2. సో ఇక్కడ నుంచి ఇక్కడ రావడానికి టైం ఎంత పడ్డది? T by 12.
T by 12.
సో ఇక్కడ నుంచి ఇక్కడ పోవడానికి టైం ఎంత అని అడుగుతున్నాడు. We know from x is equals 0 to this one. This time period is how much? T by 4. అంతే కదా? Mean to extreme. Mean to your extreme position. We know the time is T by 4. Now in order to get this one, what will we do? This T by 4 minus T by 12. So I can say
Yes,
that
sir.
time to go from your x is equals to A by 2 to A. How much? T by 4 minus T by 12. So that will be equal to how much for me? T by 6.
T minus 4.
Yeah. So this will be equal to how much for me? T by 6. Very, very,
Yes.
very important application. Okay, so I got
Yes.
from here to a T by 12. Total time is to go from mean to extreme is T by 4. So this T by 4 minus T by 12 will give me the time taken to go from your x by 2 to your E1. I did this problem a little bit detailedly because this is the first session of a classes. But as we try to increase the speed, then you can skip some steps to do the calculations easier way basically. But try to do this question twice and try to understand the way we have done. Then we'll try to go for the application of this one in the tomorrow session of a class. From tomorrow, we'll be trying to do the numericals based on this one beta in detail. Then we'll try to go for your phase angle and phase concepts also basically. Okay, na?
Yes, sir.
Okay. No
Sir,
doubts,
the
nothing.
assignment you will send, sir, today.
Yeah, I'll send because today only we got the formulas, kada. On this formulas, I'll try to send
Okay,
you
sir.
the day the assignments basically. Okay, na?
Okay, sir. Yes, sir.
Okay, chalo beta. Bye.
Thank you, sir. Bye, sir.